Hi all, Coop here. This is video 2 of the Working with Images series. In the last video we looked at how to build a very simple level, so spawning some interactive objects into our world based on the pixels of some texture 2D objects that we have in our project. So that's these here. We were just getting one of those at random, reading the pixels and then matching the colors up with some different game objects that were then instantiated in the scene when the game runs. It's a good method, but there are a couple of limitations to it. We're not going to change the way the world generation itself works. That process is perfectly fine, but currently the way it works, if we don't have these images in our project when the game is built, say if we wanted to allow the player to copy over some image files or some level files from a friend, or if we wanted to save an image file from a level in our game, then we wouldn't have it available to work with to generate levels again. So we need to look at ways that we can directly read these image files straight from the hard drive, straight from disk, and that's what we'll be doing in this video. We're going to look at the system.io namespace, which is a .NET namespace, and it's got some functions in it that we can use to read some files and to check some directories. We're going to be working with strings in order to set some paths and set some directories and file names, things like that, and we're also going to look at the persistent data path in Unity, which is a cross-platform default storage location for your games, and we're going to see how we can work with those different things. So stick around. I'm going to break this video up into some manageable chunks for you guys. I'll put the links down in the description just to sort of skip ahead to the different parts of the video, but I definitely recommend, if you haven't already, check out the first video in this series and make sure you follow along with the tutorial in its entirety if you sort of want to get the most out of it. So I won't talk too much more, we'll get started. Okay, so just before we get started on the persistent data path, we want to make a very quick change to the ReadImage script. So that's the script that we wrote in the last video. It's where we get the image and the pixels and we create our world from it. We're going to take the entire contents of it in the start function. We're going to cut all that out, so we're just leaving start, leaving it empty, and we're creating a new function which we'll call private void. We'll call it generate. Did I spell that right? I don't think I did. Generate world. And we'll give it a texture 2D parameter called image, because that's going to make our lives a bit easier. And we'll just paste all that in there and save it. Don't need to change anything else right now. We're just going to cover that persistent data path first, and then we'll get into actually doing some of the fun stuff. Alrighty, persistent data path. So what is it? It's a, very simply, it's a string that points to a location on our device's hard drive that we are going to be able to read from and write to. And there's a couple of reasons why we will use the persistent data path, or why you might generally use it in your games. That includes the fact that it is cross-platform, so you can use the persistent data path, and it doesn't matter if it's Windows or if it's Mac or Linux or Android, iOS, whatever. It's always going to, you can always use it and know that it's going to point to a location on that device that you can safely write to without the operating system interfering. So it's really good for that. And also, if you happen to save anything to this, so generally you might use it for saving states in the game, allowing the player to save files, etc. So you would generally save to this if you were also installing the game somewhere else. So if you have the game installed in one location and you update it and something about it changes significantly, the folder structure, the file structure changes massively, you're not going to impact anything saved to the persistent data path. Anything saved to that folder is going to be safe. So it's just a string that points to a location. So probably the easiest way for me to show you that is we're going to assign the data path to a string, and we're just going to print that out to the console. So the easiest way to do this is probably just going to be by saying we'll create a new string which I'm going to call data path, and it's going to equal application.persistentDataPath. It's as simple as that. That's how you get it, and we'll just print that out to a debug log and data path. Save that. So ideally when the game runs, we should just get that location. So depending on what device you're on, like we said, this is cross-platform, you're probably going to get a different output. I'm on Windows, so it'll reflect that. And we can see that there. So it's sitting on my local hard drive, my OS hard drive, the C drive, sitting under users, my username, app data local low, which if you're a Windows user, you're probably familiar with the app data folder. And there's two other things here that are of interest. The first one is this default company, and the second one is read from image file tutorial. So I'll cover those first before we have a look at the actual folder. Where are they coming from? Alright, well, the read from image file tutorial is somewhat obvious. We can see that that is also the name of the project, so it's probably getting that from there initially. But where is it setting it? If we go into edit, project settings, player, and have a quick look in here, we can see those two strings are also reflected in here. So the company name, default company, is generally set by default every time you start a new project, I believe. I'm not sure if there's a way to change that. The product name is generally set to be the project name. So that's nice and straightforward. These things in here, you would, if you were releasing a game, chances are you're going to come in here and change them at some point. So it's not a big deal to know about these, other than just simply that's why you might be getting them appearing on in your output, or when you're saving files, they contribute to that directory. So if I bring that up here, you can see that it just corresponds to a folder sitting on that hard drive. There it is there, the app data, default company, read from image file, blah blah blah. There is a Unity folder in here already, that's generally there by default, but other than that there's not a lot else going on, so I'll just get that out of the road. So that's what the persistent data path is. It's just a string that we can use. So if we start loading files or want to save a game, for example, you would use that as the directory, and then you would create your file, and you would give it a file name, and then you would tell it to write to the persistent data path plus the file name, that kind of thing. And we're going to cover some basics of that. We're only going to read the files at this point. Like I said, we're going to have the image files here. We're going to replace them, or not replace them, but just move them and use the pure PNG files themselves. And we're going to put those in that location. I'm going to be using this folder, the read from image files to image file tutorial folder, to do most of the work. That's where our image files are going to sit for this particular tutorial. So I think next thing we're probably going to have a look at is just working with a couple of those strings. So stick around, guys, and we'll get started. Okay, so far so good. As I mentioned in the last video, we're going to need to move those files around. We're going to move them from the assets folder that they're currently sitting in the project, and we're going to move them into the persistent data path folder. So I'll bring those up now. There's the asset images, and here is the persistent data path folder, the default company read from image file tutorial folder. At the moment, we've only got that Unity folder in there, so we're going to create a quick new folder here, which we're going to call level images, because they're the level images that we're using, and I'm going to cut them out of the assets folder and just paste them into this level images folder here. So that's the same folder that we have here in the project. If I go here, they're going to disappear, they're no longer in there. If you're not sure where that is, you can easily get to it by just right clicking and then show in Explorer. That'll bring it up and sort of allow you to get into that folder. We can delete that one. I'm going to get rid of it. Alright, so now the files are not in our project. They're quite happily sitting in this level images folder in the persistent data path folder. We are going to get them out of there and do some stuff with them, but first we're going to set a couple of things, a couple of strings. We're going to work with the directory. We know what persistent data path is now, and we know how to get it, so the next thing we need to do is figure out how to actually use it. So let's have a look at that script, the ReadImage script that we've been working on. We can get rid of that debug log, I think, for now. We're going to need a new variable, and this variable is going to be, it's going to contain the string that's going to tell it where to get the image files from, so the level images folder. So we're going to create a new variable for that. We'll say a private string. We'll call it, what are we going to call it? We'll call it images folder. That'll do. Images directory. That'll do. Private string images directory, and we'll just set it here. Probably it's going to be easiest. Now we're going to use a /. Even though in Windows generally you would use backslash, we're just using that at the moment because the functions we're about to use are going to, or if you notice, if I've still got it in the debug console, I'll go back to it. When we actually output that directory, when we output the persistent data path, you'll notice it's using different slashes there. So it's not the normal backslash for Windows, it's a /. Geez, I hope I'm getting them right. If I'm not, I'm going to look well silly. Doesn't matter. Oh well, pretty confident. But yeah, we're using the forward slashes, even though in Windows you normally wouldn't in this particular context. So when we're using the persistent data path and using Unity in this fashion, and the system IO, it's going to use those. It shouldn't matter. Don't stress about it. So we're going to have a forward slash here because when we append this to the persistent data path, when we add it on there, it's going to need that slash to sort of separate it. So we'll chuck that in there, and we're going to say level images, which is the name of the folder that those images are sitting in. So we have our persistent data path, and if we add onto the end of that the images directory, we should have the full path to the level images folder, which is pretty cool. Okay, so now what we probably want to do, now that we've got that, let's just set a quick string for the file name, just because I'm going to give you a bit of a quick demo. We're not going to sort of grab any files at random at this point. We're just going to grab one of them. We know they're called image and then with a number on them, so I'm just going to say image1.png because that's going to be the name of the file. We can double check that. So there it is, image1.png. That's the file we're going to get. We'll work on the other three in a moment, in a little bit. But for now, there we go. We just have one file that we're going to grab, and we've just defined its file name. So we have the full directory, we have the folder, and now we have the file name. We're going to make our lives a bit easier as well. We're just going to say that, what did I have? Images.dir. So let's make our jobs a bit easier later on in the code, and just say that images.dir is going to equal the data path, so the persistent data path plus images.dir, which when this runs should still be the level images. So we should get that full path. Images.dir is going to become the full path to the level images folder. Nice and easy. So let's just maybe debug log that for now. So let's say images.dir, we'll output it, and let's do images.dir plus, what's the file name? It doesn't have the slash in it, so we're going to put that one in. Plus, and what is it? Its file name. So let's just have a quick look at that. We should hopefully get the two directories popping up, one of them just pointing straight to the level images folder, and the other one pointing to the images, image1 file. There it is. And so the forward slash there is sticking with the convention that it's using. There we go. Alright, let's go back. That's fun, but it's not achieving a lot. So let's have a look at a couple of the system IO functions. Let's just test something first of all. I'll get rid of those debug logs, we don't need them. Let's just do a quick check, and let's say if file exists, and what are we going to use? Oops, hang on, I've done that wrong. So if file exists, then the brackets, and in that we're just going to put, let's say images.dir plus, and I think we want to do this the same way. Actually, let's make our jobs a bit easier again. Let's say that file name is going to equal, and we're going to do the same thing that we did before, images.dir plus we're going to need a forward slash plus file name. So then all we've got to do actually is just say file name. So if image1 exists in that directory, so if the image1 file exists in the level images folder in the persistent data path, let's just debug out simple one-liner file exists, just to see that it's working. And we can do an else if it doesn't. We'll say debug log file does not exist. Cool. So in theory, if I turn that off and we run it again, the file does exist, so we should get a debug log coming back saying that it exists. Nice and easy. There we go. So if we come in here and let's change that file name. Let's just show what happens if it doesn't work. Let's say image 10. We don't have an image 10. So in theory we should get that the file does not exist. There we go. So that's using a pretty simple function. It's a very nice, easy way to check to see if a file is there or not. I'd highly recommend you do use these functions just to catch any errors before they can occur. So we've seen how to do it with the file. let's see how to do it with a directory. So if directory exists, and how can we do this one? Well, we've kind of ruined the images already. No, we haven't. I can actually use it. Let's just say images. So if the folder, the level images folder exists, you know what? Let's just copy paste this. There we go. We'll change that. Now, in theory, if I've got that right, if I've thought about that right, this should work, and we should get that the directory exists. Dir exists. There we go. The file does not exist currently because we still have it set to 10. Just change that back to 1 for fun. But there, we're doing a quick check. We can change. Well, I could show you the same thing with the directory, but we don't really need to. We sort of know how that's working. So, 2 very quick and easy checks that you can do there using the system.io functions. We can do a check for a file to see if a particular file name, so in this case the file name is actually the full file name, so it's the full path and file name. It's persistent data path plus the image, the level images folder, plus the file name with a forward slash in between each one, and we just do a check on that saying, you know, if that file under that path exists, then do this. If it doesn't exist, then do that instead. And then we do the same thing with the directory, just giving it that level images folder. And the folder does exist, so we got that in response. But if it didn't, in theory, we should get back that it did not exist. So we're going to work with that now and start building the first sort of attempt at reading that file and turning it into a level. So we're making some pretty good progress here. We've managed to define our directories and our file name and file path, etc. We're going to move on to actually using that now to basically do what we did in the first video. We're going to run this generate world function, and we're going to feed it a texture 2D that we get from one of the image files. So I'm going to keep this singular. Again, at this point, we're just going to get one file and we're going to turn that into a level, and probably in the next part we'll expand on that and create an array of textures from the file. But for now, we'll just focus on one. So I'll get rid of these if file checks, etc. We'll just get rid of all of that. We'll keep the file name, we'll keep the images the way they are, I think. We'll focus on image 1 for now. So where is that? Where's image 1? Let's have a look at that. So if we have a look at image 1, this is the shape we should be ending up with. Nice and easy. Okay, so how do we go about it? Alright, well, we can pretty much use what we've looked at. We're going to have a couple of extra functions in here, though. We're going to use some functions to actually read the file and then feed that back into a texture. But for the meantime, we can sort of just replicate a couple of the things we've done already. So, just as mentioned, for safety's sake, let's do a couple of checks. So let's say that if directory.exists, we'll do the images. So we want to check to make sure that that folder has actually been created. If it hasn't, then we're going to create errors when we try and get the file, or when we do a file exists. So it's good to check that first, make sure the directory is actually there. We'll add in a debug just to catch if it isn't there. It's not likely to, but you know, we'll do it anyway. Not found. Let's say, and we can even just print that out if we wanted to. So images dir. So that'd give us a nice error. If the directory wasn't there, we'd get a dir not found to represent that the directory is not there, and it would also tell us the directory that it's looking for. In this case, it's going to be that level images folder. So if it does exist, then the next thing we probably want to do is, we've already got the file name. The file name is the full path, so we don't need that. So I'd say we can probably move straight on to saying that if file.exists, and do the same for file name. And I'm going to pinch that debug log. Whoops. No, what have I done? There we go. Copy, not cut. And we can do the same here. File name, where is it? There it is. So once again, if the file doesn't happen to exist, we're going to get a nice error telling us that it's not there, can't find the file, and it's going to tell us which file it's looking for, which is definitely a helpful thing to do in an error, I think. Okay, so if the file exists, what do we want to do? Alright, the first thing we need to do is, and the way we're going to be reading these files is we're going to be reading, we're basically just going to be reading all bytes in the file. Because it's an image file, it should feedback nicely, it shouldn't be a problem, and we're going to store those bytes in the file into a bytes array, which is easy to declare, not a problem at all. We just say byte, declare it as an array, We'll give it a name, we'll call it image data. It's the data of the image that we're getting, and we're just going to say file.readAllBytes, and you'll notice there are some other functions there as well. Definitely worth having a look at those. Definitely Google these functions, Google the file class, and have a look at some of the things it can do. But for now we're going to do readAllBytes, and we're just going to give it the file name. So we're giving it that file, the whole file with the path, basically like we've been doing with all the other functions. So it wants the full file, path, and name, and that's what we've given it. We're going to create a new texture 2D, there it is, and we'll just call it, I don't know, level text, that'll do, or we'll just call it text. That's nice and easy. Text is going to equal new texture 2D, and when we create that, it wants two things. It wants a width and a height. Doesn't really matter what we give it at this point. We're just going to give it 1, 1, just to create that initial texture, give it the parameters that it needs, and now we're going to load the image into it, and we're going to do that with text, so the texture, and load image. So you'll see there, once again, there is another function that can be used. You can read in some bytes another way, but this one should be fine. Here we can just do the load image. We're going to basically, this is going to be nice and easy. All we need to do is give it that array, the image data. Done. Cool. Okay, so we've managed to create the texture 2D that we need, and we've managed to load in the image1 file. What do we want to do now? Let's go down to our generate world function. As we know, we're going to give it a texture 2D, so we can easily just do that now. Let's say generate world, and we're just going to give it text, so the texture that we created. We need to adjust this a little bit too, so instead of having this here, we don't want to get one at random anymore. We're just going to easily say that, just basically kick it off from image, because image is the name of the parameter that we've created, so we can just kick the whole process off using that one. We don't need to get one at random. That was just for the last video. We don't do that now. We just give it that image, and we use that image to complete the rest of the process. So with a bit of luck, if this is all working and I've not done it wrong, if I hit play, we should get image 1 in the game as the level. We should get a level based off image 1. That's what I'm trying to say. There we go. Nice. So exactly the same as it was before. It's still creating the world the exact same way, just this time we're just giving it a single image, which we're getting from that image1 file, which we're reading straight from the disk. You all still with me? Good, good. We're on the final stretch here, guys. Don't worry. This time we're going to have a bit of fun. Instead of working with a single file, we're going to load in all the files, all of those images, and we're going to save them back to that images texture 2D array that we were using initially. I'll get rid of the private image here. We don't actually need that at the moment, but we do want to keep this texture 2D array. I'm going to use that. We're going to fill that full of the images, and we're going to pick one out of that to load the level. So we'll get rid of the string file name. We don't need that anymore. We're not going to be working with a single file just yet. We need to get a list of all the files. So we can still use the directory exists. We will use that, but we'll get rid of everything within it. So to start with, we need to get a list of the file names, and the easiest way we can do that is simply by saying, or creating an array of strings. We'll call it files found, and it's going to equal directory. We're using that again, the directory class, and it's going to equal directory.getFiles, which pretty much is as it sounds. It's going to get all the files within the directory that we give it, and the directory that we give it is once again going to be the images.dir, so that full directory there. Okay, so now that we've got that, we can sort of assume that we've got some files in there, but we probably want to do a check as well. So let's do a if files found dot length is greater than 0 if there are actually some things in that array, else, and we'll just put an error in here, debug.log no files found in, and we can just give it the, what is it, images.dir, just to create a little error there. So if we do happen to have something in that array, if we have found some files, what are we going to do? Alright, so before we go any further, I'll probably show you something here that might throw you around if you're not aware of it. Let's do a quick for each loop. Let's actually have a look at what's in that array now, in the files found array. So we're going to say for each string, what it'll be, file and path in files found. What do we want to do? Let's just debug log them out. We'll say, what is it? File and path 1. Oh, file and path, just so we can identify that a bit more easily. And we'll say file and path. And you'll see why I'm calling it that in a second. But yeah, so you're running this function, right? You're running the files found and you're saying, you know, get all the files in that directory. If you're like me, you're probably going to assume off the bat that you're going to get a list of the file names. But if we actually run this and have a look at what we get in that array, when Unity catches up, it's on an SSD. I don't know why it does this. There we go. You'll actually see that we're getting some rather interesting results. So if we have a look at this file and path, we get the whole path there, but then it's getting the file name and it's sort of appending it on there with a slash that's completely different. So if we try and read that, it might actually have a bit of an issue. So we're going to need to modify that a little bit. So let's have a look at how we can do that. Okay, so before we do the for each loop, we might actually want to add a couple of things in. We're going to say that images array is going to equal a new texture 2D array, and it's going to be the same length as files found dot length. We are going to use that in a second, but we'll just set that up now. We're going to create a counter as well. Let's call it counter, because I like doing that, and it's going to equal 0. And now we're going to do the for each loop. So there's a couple of things we need to do in this. As we saw, the string we're getting is a little bit strange. The file and path string we're getting back's a bit odd. We're getting a strange sort of slash in there. We're getting the backslash instead of a forward slash, which isn't what we want. So what we're going to do is we're going to say that string, we're going to use file name. Here's us picking or actually setting an individual file, getting an individual file. It's going to be file and path substring. So we're going to get a part of that file and path string. So if you haven't used substring before, basically there's a few ways you can use it, but what we're going to do is we're going to give it an integer. We're going to give it a number, and that number is going to represent what the character in the string, so the character in the file and path string that we want to start with, and then it's going to get the rest of the string after that. So we're cutting off the end of the string. We're going to start from the backslash, and we're going to get everything after that, which should give us the name of the file. As we saw from that debug log there, the file and path is the full path, then we get a backslash, then we get the name of the file. Go away. So what we want to do is we want to find that slash in this string, and then everything after it we want to store as a string. So we're getting the name of the image or the name of the file only. And I hope that makes sense. So we're using substring to do that. If you're not familiar with substring, I recommend have a bit of a look at it. It is a very good little function to understand and to use, and it's very, very common. You'll use it in lots of different languages and all over the place, so have a look at that one if you don't know it. And we're going to use another fun little part of substring, and we're going to find the last instance of the backslash, and we're going to do that by saying file and path last index of, and now we need to give it a backslash. So it's a bit interesting here the way we do it. If we give it a single slash, the compiler is actually going to interpret that a little bit strange. It's not going to see that as a slash in regards to a string. It's not seeing that as text. It's seeing that as part of the code. So the way we get around that is by using the special character, a double backslash. So that actually tells the compiler to use a backslash there. It's not a part of the code, it's a part of the string. So we're finding the very last instance of a backslash in the file and path string. Now we know there's only one, it's right at the end before the file name. So once we found that, we just say, alright, the very character after it, so +1 to this, because we're giving the substring a number. So +1 will give us the character after the backslash, and that string there, the file name, should end up just being like image1.png or image2.png. It'll cut the whole thing off from the start and just give us that end. which is what we want. We want the file name in this case. So, excuse me, like we did above with the images.dir, we're going to set up a string, we're going to create a new string, and we're going to call it file path. This is going to be the full path to the file and the file name, because now we want to reverse that slash. We want to turn the backslash into a forward, and we're going to do that with, what is it? It's images.dir plus, and we don't have to do this for the forward slash. The forward slash is fine. It's not used in code in the same way, so we don't have to do the special character. Images.dir plus a forward slash plus the file name. So that should give us, like we had before, the full path and the file name, all using the correct forward slash. Okay, we could log that out, but I hope you're just gonna trust me. That's what we'll get. We'll get the we'll get the full file path and name, all with the correct slashes. So we're gonna do a file exists to check to make sure that the file we've just sorted out all the strings for is actually there. This is gonna catch any errors if we've made any mistakes in the code here, and we're gonna give it the file path. So once again, the full path and the file name, and we'll do an else. I'm just gonna pinch that. We don't need to print that out, we know what it's giving us. File not found. File path. Same as before. Exactly the same as we have been doing. So what do we do if the file exists? Pretty much exactly as we were doing before. So we're going to say byte array image data is going to equal file dot read all bytes, and we're going to give it that file path. So we're doing this within the for each loop, so it's going to do this for every single file that it finds. So we read the file, same as before. We're going to create a temporary texture 2D. We'll call it text again. It's going to equal, not text, it's going to equal new texture 2D 1 then we're going to fill that texture, we're going to fill that new texture with the image. So load image, same as before. We give it image data, and then we're going to increment counter. Now we just need to assign that new image to the array, so we'll actually do that before counter, my mistake, and it's going to be really easy. We're just going to say that images, and the element we want from images is going to be counter, because in theory that should match up with the file that we're currently working with. Images counter is going to equal text. Is it text we want? Yes, it's text. That's what we want. So that should do the trick. That should build, or sorry, not build, but fill the images array with a bunch of images, a bunch of textures, texture 2Ds, which it's getting from those files. Exactly the same way as we did before, but this time we're just basically going through every single file and, yeah, filling that array with them. So let's have a bit of a look. Hopefully that should work, and we should actually get a nice visual representation of this in the inspector window as well. So we'll just move that back, and if we click on the image reader here, so we can see we've got that array there already. I'm just going to set that to 1. Not even that, let's set it to 0. So right now we don't have any images in the images array. We know what our files are. Where are they? Here they are. We've got image 1, 2, 3, and 4.png. If we run this, actually, if we run this, what's it going to do? If we go to generate world, we're not running generate world. It's just going to fill that array. You know what? That's okay. I'll show you that. So let's run it, and we should get that array filled with the images. There we go. So once again, they're not in our project. We don't have them here. They're just simply being read in from disk and stored to the array. We can sort of have a bit of a look at it. I don't know if any of these settings will impact it. Let's find out. Let's have a bit of a look. Let's add in the actual generation now. So after we've done all this, where could I put it? I'll put it after the for each loop. So I'm just going to use this as an example. You can do this however you want. The point is here, you've got an array of images that you can pick from now. So probably like we did in the first video, I'm just going to say generate world. I'm going to grab it from the images array, and I'm just going to pick one at random. Random.range between 0 and images.length, which will just give us one of those images out of the array after the for each loop has finished doing its thing. Should generate a world as well, and we should be able to see that. There we go. So ironically, it's picked image 1. I don't believe that's in the code. Let's see if we run it another time, if it actually picks a different one. And because I'm recording, it's going to pick the same one. Oh, no, it didn't. There we go. You can see that there. So it's picking one out of that array at random, and you can see all those images there. It's all, everything else is exactly the same as it was in the initial video. We've sort of just sort of expanded on that process and allowed it to read in those files from the disk, which I'm hoping will be helpful to some of you guys, and I'm hoping you're going to be able to use this in your games. The thing to sort of look at here is, like, while we're doing it with images, you could load in anything, really. You could load in a text file and you could work with it in a very similar fashion. It's a really cool little function, a really cool little way to do things. So, you know, you could now allow your players to import in their own images and work with them and things like that. It's just a cool little function that I think you can add to your games. As always, thanks for watching. Please like and subscribe if you haven't already, because it really helps me out and it helps my channel to get a bit of exposure. To my Patreon supporters, thanks again. You guys make these videos possible. If you have any thoughts, any questions or feedback, even if you just want to have a bit of a chat, get in contact with me. You can leave me a comment here, or you can jump in our Discord server, where we are always happy to have new people. Finally, if you like any of my work, if you're interested in any of the things that I do, or you would just like to support me in some way, there are plenty of places that you can find my work online. I'm on GitHub, on itch.io, and on the Unity Asset Store. I also run a Patreon page where I upload all the project files and materials from each of my tutorials for supporters to have access to, as well as some other cool little benefits. Have a look if you haven't checked that out already. Finally guys, I hope this video helped you out. Thanks again for watching, and good luck in all your future game dev adventures.